Welcome to the deep dive. Today we're cracking open a really interesting chapter 6 from Ultimate Full Stack Web Development with MEVN by Bhargav Bachina.
That's right.
We're diving into backend development, specifically building APIs with Express and TypeScript.
It's a fantastic resource. Chapter 6 really lays out the blueprint for building a solid backend.
Our goal here is pretty simple. Pull out the key insights for you, our listener. We want to make sense of things like API structure, REST, middleware, all that stuff that makes a modern web app tick.
Exactly. It's about understanding the why behind the structure before you get lost in the how. We'll look at everything from setting up the server to validation.
Yeah, cutting through the jargon, showing why these aren't just buzzwords, but like essential pieces for a secure, efficient API.
So let's unpack it. From structure, setting up Express, using Webpack, defining routes, building controllers and services, right through to request validation. It's quite a journey.
Let's do it. Okay, first stop. The big picture. Understanding the API structure, why is it so crucial to actually think about how an API is designed, especially, for keeping it manageable long term?
That's a great question. I mean, you could just dump all your code in one file, right?
Right. Tempting sometimes.
But this chapter really emphasizes a structured approach, something like MVC Model View Controller. The core idea is separation of concerns.
Okay, separation of concerns. So breaking it down.
Precisely. Organizing your code into logical parts. Think of it like having different drawers for different tools. You know where everything is.
Instead of one big messy toolbox. So the book suggests a typical structure for Node.js with Express using specific directories inside SRC. Can you walk us through those?
Sure. You typically see controllers. These guys are like the traffic cops. They get requests from the routes, figure out what needs doing, tell the services, and send back a response.
Got it. Traffic cops. What's next?
Then services. This is where the real work happens, the core business logic. Database stuff, calculations, talking to other APIs. Controllers call these.
So the heavy lifting is in the services.
Their ranks.
Okay.
Pretty straightforward. They define the URLs and HTTP methods like GDT or POST and point them to the right controller function. They're the maps.
The map, okay. And requests and responses.
Yeah. These define the shape of the data. What should an incoming request look like? What should the response look like? Using TypeScript interfaces here is key for consistency and, well, catching errors.
That makes a ton of sense. Defining the contracts for your data. And the chapter also mentions two specific files, app.ts and index.ts. What do they do?
Right. App.ts is like the main configuration hub for Express. You set up global middleware, connect your routes, maybe configure error handling. It defines how the app behaves.
The control panel.
Kind of, yeah. And index.ts is simpler. It's the entry point. It actually creates the server instance using the config from app.ts and tells it to start listening on a specific port, like 3080.
Okay, clear division, config separate from startup. That structure seems really logical for keeping things manageable.
Absolutely. It's foundational for scaling.
All right, so we have the structure, but how do we design the interactions? This brings us to REST architecture. What exactly is REST? Why is it, everywhere?
REST representational state transfer. It's not a protocol like HTTP. It's more an architectural style, a set of guidelines from Roy Fielding back in 2000.
Oh, style. Okay.
Yeah, and it became the standard because it leads to scalable, maintainable web services. It's about making interactions predictable and efficient, like standardized road signs for the web.
Standardized road signs. I like that. So predictability. The book lists 6 core principles. Which ones are really the most important for defining a RESTful system?
Good question. The big ones are definitely client-server separation keeps them independent, helps scaling. Statelessness is huge.
Statelessness. What does that mean practically?
It means each request from the client has to contain all the information the server needs. The server doesn't remember anything about the client between requests. No server-side sessions tracking state.
Okay. So every request is self-contained. I can see how that simplifies the server and helps scaling.
Massively. Then you have cacheability, which is crucial for performance, letting clients reuse responses. And the uniform interface, that's probably the most defining characteristic.
Uniform interface. That sounds important, but a bit abstract. What does it actually involve?
It breaks down into 4 parts. Resource-based, everything's a resource identified by a URI. Manipulation through representations, you get enough info back to change or delete the resource. Self-descriptive messages, things like HTTP headers tell you how to process the message. And then there's HTOs.
HTOs. Hypermedia as the engine of application state. That's always sounded complicated. What's the core idea?
It sounds complex, but the idea is simple. The server guides the client. Responses don't just contain data, they contain links to related actions or resources.
So the API tells the client what it can do next.
Exactly. Like browsing a website, you click links. You don't guess URLs. This decouples the client and server. The server can change where things are, add new actions, and the client discovers them dynamically through these links.
Wow, okay. That sounds incredibly powerful for letting APIs evolve without breaking things constantly.
It's a game changer for long-term maintainability, yeah. Often overlooked, but really important.
Makes sense. And speaking of interactions, the HTTP methods get, post, put, delete, the book calls them verbs. They're the actions we perform on resources, right?
Spot on. They signal the intent of the request. Get is just for retrieving data should be safe, no side effects. Post is generally for creating new things or actions that aren't straightforward updates.
Like signing up a user.
Exactly. Put it replaces an entire resource. Delete removes it. Then you have patch for partial updates, head for just metadata, options to see what methods are allowed. Using the right verb is key for clarity and following REST principles.
Got it. And the overall advantages of using REST. The chapter lists quite a few.
They're pretty compelling. Scalability, simplicity using standard HTTP, flexibility with formats like JSON, portability. It's standards-based, so lots of tools support it.
Yep.
It just leads to better designed distributed systems.
More maintainable, easier to understand. Okay, that makes sense.
Yeah, it's the de facto standard for a reason.
All right, so we have the structure and the RESTful design principles. Now, how does Express actually process these incoming requests? This is where middleware comes in. What exactly is middleware?
Middleware functions are like the heart of Express's request processing. They're functions arranged in a pipeline. Each one gets the request object, rec, the response object, res, and this crucial next function.
A pipeline, okay. And next passes control along.
Precisely. A middleware can do anything. Run code, change rec or res, and the request response cycle by setting a response, or .call next to pass the request to the next middleware in line.
And if it doesn't send a response, it has to call next.
Yes.
Yeah.
Otherwise, the request just stops dead, hangs there. Definitely not what you want.
Right. Bad user experience.
It's very bad. And the cool thing is their versatility. You can have middleware that runs for every single request that's application level, or just for certain routes, router level. Special ones for error handling. Built-in ones provided by Express.
Like what?
Like Express.static for serving files, or Express.json, which is super important, and tons of third-party ones for logging, authentication, cookies, you name it.
You mentioned Express.json there. That sounds familiar from the setup part.
It is. It's built-in middleware that parses incoming requests with JSON payloads and makes the data available on rec.body. Absolutely essential for modern APIs.
Okay, that connects back nicely. So middleware forms this processing chain. Makes sense. Now let's get practical again. Setting up the actual Express server.
Right, the nuts and bolts. First, obviously, npm install Express.
Standard stuff.
But since we're using TypeScript, we also need the types. npm installed std, it types Node, it types Express. Those are development dependencies.
Why the extra types? What's the big deal with TypeScript here?
Well, TypeScript adds static typing, catching errors early. But the key configuration happens in tsconfig.json. The book calls it the backbone.
Backbone, okay. What does it control?
A lot. It tells the TypeScript compiler how to work, what JavaScript version to target, like ES 2019, what module system to use, CommonJS for Node.js, is vital. It enables strict type checking for better code quality, lets you set up path aliases for cleaner imports. It defines what files to include or exclude, like Node modules.
So it's way more than just compiling TS to JS. It governs the whole development experience.
Absolutely. It ensures consistency, helps your IDE provide better assistance, and makes the project more robust, especially as it grows.
Got it. Then in app.ts, we configure Express. The book shows using express.json and express.erlang-coded.
You mentioned JSON. What about Erlang coded?
Right. So express.json handles JSON request bodies. Express.erlang coded handles data coming from traditional HTML forms, the stuff that gets URL encoded.
Ah, like form submissions. Exactly. Putting these near the top of out.ts means pretty much any incoming data gets parsed and put neatly onto rec.body for your route handlers. Super convenient. The extended true just allows for richer data structures in that form data.
That saves a ton of manual parsing work. Okay, and finally, index.ts just starts the server on a port like 3080.
Yep. It imports the configured app from app.ts and calls app.listen. And boom, your API is live. Running npm run dev usually gets it going with tools that watch for changes.
Nice. Seeing it run is always a good moment. Okay, next topic, Webpack. The book calls it a powerful module bundler, but isn't Webpack mostly for front-end stuff? Why use it on the back end?
That's a common reaction. And historically, yes, it was mainly front-end, but it's incredibly useful for back-end TypeScript projects too.
How so?
It takes all your TypeScript files, all their imports, all your dependencies, and bundles them into one, or maybe a few, optimized JavaScript files. It handles the TS to JS compilation via loaders.
So it's about optimizing the build process for Node.js.
Exactly. For production, a bundled backend can start faster and be easier to deploy. Plus, Webpack has features like loaders for different file types. TS loader is key here. Plugins for optimization, and even things like hot module replacement, which can speed up backend development too.
Hot module replacement on the back end. Interesting.
Yeah, lets you swap out modules without a full server restart sometimes, speeds things up.
So the setup involves a webpack.config.ts. What are the key parts of that file for a backend build?
You tell it the entry point, our index.ts, the output path and file name, like distepi.bundle.js, how to resolve file extensions.tsjs, and crucially, you configure the module rules to use TS loader for .ts files, and importantly, you set target.node, so it bundles correctly for the node environment, not a browser.
Target.node. Got it. So npm run build uses this config, compiles everything into distepi.bundle.js, and then you just run node distepi.bundle.js to start your production server.
That's the workflow. Streamlines development to deployment.
Very cool. Okay, server's up, code's bundled. How do we actually make it do things based on URLs? Defining routes.
Right. This is where we map URLs and HTTP methods to our controller actions. But first, the chapter stresses handling unhandled routes.
Meaning if someone goes to a URL that doesn't exist?
Exactly. You shouldn't just let it crash or show an ugly error. You need a specific handler that catches all unmatched routes and sends back a proper 404 not found response.
Why is that so important? Just tidiness.
Tidiness, yes, but also security prevents leaking information. And maintainability makes it clear what paths are valid. It's a basic best practice.
Okay, handle the 404s. Good tip. Now, for the actual API routes, like for users or todos, how does the book suggest structuring them?
It uses a modular approach, a central ap.ts router that then delegates. So you'd have maybe apsroutes.ts and aposrs.ts.
Separate files for user routes and to-do routes.
Yep. So under APOS, you might define POA sign-in and POS to sign-up. Under APOS, you'd have POS to create, get to list, get t.id to fetch one, put.id to update, delete.id to remove.
Following REST principles with the methods and paths.
Precisely. This keeps related routes together, making the code base much easier to navigate and grow. Then, back in app.ts, you tell Express to use these modular routers, like app.use, aposrs user routes, and app.use, app.use tutor routes.
So app.ts connects the base paths to the specific router files. Separation of concerns again.
You got it. Keeps things clean.
Okay, routes are defined. Now we need to build the actual logic behind them. The controllers and services, we touched on them earlier, but why the separation?
It's crucial. The services contain the core business logic. The chapter uses examples like a user service handling sign and sign up, even if it's just dummy logic initially, and a Toto service handling CR-reads for tasks, maybe just in memory to start. Services do the actual work.
They don't know about HTTP requests or responses.
Exactly. They just take input, do their job, talk to a database, calculate something, and return a result or throw an error, completely decoupled from the web layer.
And the controllers then, what's their job?
Controllers are the bridge. They understand HTTP. They take the rec object, pull out necessary data, like user input from rec.body or ID from rec.params, call the appropriate service method with that data, get the result back from the service, and then format the res object to send the response back to the client, like sending JSON data or a status code.
So controllers orchestrate the flow, request, service, response.
Perfectly put. Services are the doers, controllers are the orchestrators. This separation makes testing easier too. You can test services without needing a running web server.
Makes sense. And the book also emphasizes using TypeScript interfaces for defining the shape of requests and responses again here.
Absolutely. Things like signet request, task, toter response. Defining these interfaces provides type safety. It acts like documentation and helps your IDE catch mistakes if you try to send or receive data with the wrong structure. It ensures data integrity throughout the application.
Like a contract for your data. Adds confidence. So the updated routes now call these controller methods, which in turn call the service methods.
Exactly. Connecting all the pieces.
Okay, we've built the structure, routes, controllers, services. It feels pretty solid. But what if someone sends, well, garbage data? Maliciously or just by accident? This brings us to request validation. The book says its importance cannot be overstated. Why?
It's your first line of defense. Think about it. What's the point of all this careful structure if bad data can just waltz in and crash your service, or, worse, compromise security?
Right. So number one is data integrity.
Definitely. Ensuring only valid, well-formed data gets processed. And closely tied to that is security. Validation blocks things like injection attacks or unexpected inputs that could exploit vulnerabilities before they even reach your core logic.
So it's a security essential. What else?
Better error handling, you send clear errors back to the client immediately if their input is bad. Saves server resources because you're not processing invalid requests. Improves user experience with that fast feedback. Enforces business logic rules at the entry point. Can even help with regulatory compliance. And honestly, it simplifies everything downstream because your controllers and services can trust the data they receive.
That's a lot of benefits. It really does seem crucial. The book mentions libraries like Joy and Express Validator. The deep dive uses Joy. How does Joy work?
Joy is really elegant for this. It's a schema description language. You define a schema object that describes exactly what your expected data should look like.
Like, this field must be an email, this one a string with min-max length, this one a number.
Precisely. You can get very specific. Is it required? Does it match a pattern? Is it one of several allowed values?
Okay, so you define these schemas. Where do they live?
Good practice is to put them in separate files, maybe user-validations.ts and totos-validations.ts. Keeps the validation logic organized.
And how do you use them?
In your route handler, or often better, as middleware before your route handler. You take the schema, call schema.validate on the data you want to check, like rec.body. Joy tells you if it's valid or not. If not, it gives detailed error info.
So the middleware checks the request body against the Joy schema.
Yep. If validation fails, the middleware sends back a 400 bad request response immediately, with details from Joy about what was wrong. The request never even reaches your main controller logic if the data isn't right.
Wow. So it acts as a gatekeeper right at the entrance to the route. That's incredibly powerful for ensuring clean data reaches the core application.
It's a fantastic safeguard. Clean, organized, and highly effective.
Okay, that covers a lot of ground. We've really gone from the high-level architecture down to the implementation details.
We really have. We started with that foundational API structure, the importance of separation of concerns, then setting up Express with TypeScript, leveraging Webpack for an efficient build.
Defined RESTful routes, built out the controllers and services following that pattern, and crucially, added that layer of Joy request validation.
It gives you a solid, structured, and secure backbone for a web application. From here, the next logical step the book would likely cover is integrating a real database, like MongoDB, to make it dynamic.
Absolutely, bringing in persistence. So we've built up this layered understanding. Here's a final thought for you, our listener, to mull over. Considering all these layers we've discussed, the network protocols with REST, the internal application structure, the validation gates, how does having this deep understanding of the backend fundamentally change how you might approach debugging when something inevitably breaks in a complex, large-scale web application? Where would you even start looking?
That's a great question to ponder. Knowing the layers helps you isolate problems systematically. This has been The Deep Dive. Hopefully you feel a lot more comfortable navigating the world of backend development now.
Until next time, keep digging deeper.